In previous video, we discuss about the relation between the operator, forward difference operator, backward difference operator, and displacement operator. And now we discuss in this video the relation between the operator delta, nabla, E and capital D, where capital D is the operator of differential calculus. In calculus of finite difference, we deal with the ratio of simultaneous increment of mutually dependent quantities, while in differential calculus we find the limit of such ratios when the increment tends to 0. It means differentiation of fx is equal to d by dx of fx is equal to limit h tends to 0 fx plus h minus fx upon h. From the Taylor series, we know that fx plus h is equal to fx plus h f dash x plus h square by factorial 2 f double dash x plus up to h की power n upon factorial n fn x. This is equal to fx plus h. F dash x is can be written as differentiation of fx. So d of fx plus h square by factorial 2 d square of fx plus h की power n upon n d की power n into fx. Taking fx as common, then we get 1 plus h into capital D plus h square upon factorial 2 capital D square plus up to h की power n upon factorial n d की power n into fx. And this is the expansion of e की power h into d into fx. This is our relation number 1. And we also know from properties that fx plus h is equal to displacement operator of fx. So from 1 and 2 using, then we get the displacement operator E is the equivalence relation of e की power h into d. And we know very well that the value of displacement operator E is equal to 1 plus delta, a forward difference operator delta. This is equivalence relation of e की power hd, or we can write it as hd is equal to log e 1 plus delta. Now expansion of log of 1 plus x form, we get h into capital D. This is equal to delta minus delta square by 2 plus delta cube by 3 minus delta 4 by 4. Or differentiation operator D is equal to 1 by h into delta minus delta square by 2 plus delta cube by 3 minus delta 4 by 4 plus next term is same. And we can also define that the inverse displacement operator is equal to e की power minus h into d, and inverse displacement operator E is equal to 1 minus nabla. So 1 minus nabla is equal to e की power minus h into d, or hd is equal to minus log of 1 minus nabla, or d is equal to 1 by h into nabla plus half of nabla square plus 1 by 3 nabla cube plus another term of this. Now we can write in any equation in factorial functions notation. Suppose this method is known as method of synthetic division. Suppose fx is equal to x4 minus 12 x cube plus 42 x square minus 30x plus 9. This expresses the following function and its successive differentiation in the factorial function rotation. Because fx is equal to x4 minus 4x cube plus 12x square plus 42x square minus 30x plus 9. Solution of this, suppose this is equal to a into x की power 4 plus b into x की power b a into क्रमगुणित फलन of 4 time b into x 3 plus c x into 2 plus क्रमगुणित d into x 1 plus e. So the solution of this first, second, third, 5, we write down the coefficient of x की power x की 4 term, x की power 4, x की power 3, x की power 2, x 1 minus 12 40 minus 30. In left hand side we take 1, this is multiplied by 1 into 0, 1 into 1 minus 1 into 1, then we take value of e, d, c and b in 1. So that in factorial notation we can write is fx is equal to x factorial notation 4 minus 6x 3 times plus 3x2 plus x1 plus 9. In factorial notation simple differentiation. Similarly we get first differentiation, second differentiation, forward difference, third forward difference, and fourth forward difference, and 5 forward difference. So we can write an equation in the factorial notation term. Now next topic is the difference of 0. If n and m be positive integer, then we have n time forward difference of x की power m is equal to e minus 1 की power n into x की power m, which is equal to e की power n minus n c1 e की power n minus 1 plus n c2 e की power n minus 2 plus next term is this into x की power m, which can be written as x plus n की power m minus n c1 plus x plus n minus 1 की power m plus n c2 x plus n minus 2 की power m plus another term this. Interval of differentiating is be taken as unity. Now put x is equal to 0, then n time forward difference of x की power m at x is equal to 0 is equal to n की power m minus n c1 n minus 1 की power m plus n c2 n minus 2 की power m plus same n c n minus 1 into minus 1 की power 1. This is equation we write as the equation number 1. So the expression n time forward difference of x की power m at x is equal to 0 is written as forward difference of n time of difference of 0 and written as forward difference n into 0 की power m. So the quantities are known as difference of 0 because the leading term is always 0. For n is equal to 1, m is equal to 3, for we get value is 1. For n is equal to 2, m is equal to 3, we get value is 6. When n is equal to 3 and m is equal to 4, we get value is 36. When n is equal to 5 and m is equal to 5, then we get value is 120. Similarly, we get another result. If the difference of order higher than m, then all value are at 0. If n is greater than m, then n time forward difference of x की power m is equal to 0, because n time differentiation of difference of 0 is equal to forward difference n time x की power m at x is equal to 0, and this is equal to 0 into x is equal to 0 is equal to 0. Now we define the recurrence relation. Recurrence relation between the n time differentiation of difference of 0 into n minus 1 time difference of m minus time of 0 and n time difference of m minus 1 time of difference of 0. So proof for this we can write from left hand side. This is equal to n time difference of 0 is की power m is equal to n की power m minus n c1 n minus 1 की power m plus n c2 n minus 2 की power m minus next term is this is equal to plus n c n minus 1 की power n minus 1, which can be written as this is equal to n की power m minus n minus 1 की power m plus n minus 1 की power factorial 2 into n minus 2 की power m minus plus n into minus 1 की power n minus 1. Taking n common, then this is equal to n into n की power m minus 1 minus n minus 1 की power m plus n minus 1 upon factorial 2 into n minus 2 की power minus m plus minus 1 की power n minus m. Taking n common, then n this is equal to n into n की power m minus 1 minus n minus 1 into n minus 1 की power m minus 1 plus n minus 1 n minus 2 upon factorial 2 n minus 2 की power m minus 1 minus आगे की term similarly. This is equal to n into if we adding 1 and subtract 1, then we can write it as n into 1 plus n minus 1 की power m minus 1 minus n minus 1 into c1 n minus 1 की power m minus 1 plus n minus 1 c2 n minus 2 की power m minus 1, which can be written as this is equal to n into 1 plus n minus 1 की power m minus 1 minus n minus 1 c1 1 plus n minus 2 की power m minus 1 plus n minus 1 c2 1 plus n minus 3 की power m minus 1. If we take at x is equal to 1, then this can be written as n into x plus n minus 1 की power m minus 1 minus n minus 1 c1 x plus n minus 2 की power m minus 1 plus n minus 1 c2 x plus n minus 1 n minus 3 की power m minus 1 plus another term is same. But we know very well that value of this can be written as if we taking x की power m minus 1 common is taking common, then this is equal to n into e की power n minus 1 minus n minus 1 c1 e की power n minus 2 plus n minus 1 is to n minus 3 time of displacement operator into x की power n minus 1 at x is equal to 1. This can be written as n into e minus 1 की power n minus 1 into x की power n minus 1 at x is equal to 1. This can be written as n into e minus 1 की power n minus 1 into x minus 1 at x is equal to 1, which is can be written as n into n minus 1 time delta n minus 1 into 1 की power n minus 1, and which is can be written as n into delta n minus 1 of e की power, because e की power e displacement operator e of 0 difference is equal to 1 and e is equal to 1 plus delta, and we get the required recurrence relation. So we can express the difference of 0 and an equation in factorial notation: forward difference, backward difference, displacement operator, differentiation of d, and all these result is very applicable in the field of research and engineering. Thank you.